All of you, and as you have seen the question on the thumbnail, given that A, B, C, D are position vectors of 4 points of a tetrahedron. So we have A, B, C, D, and these are position vectors of 4 points of a tetrahedron. So let's say this is A, we have another point B, let's say we have this point as C given by position vector C, and this is D vector. Now as the question tells, we have to consider a set X which contains all these composition of vectors x3c plus x4d such that this sigma xi x1 plus x2 plus x3 plus x4 equals to where xi belongs to natural number union 0, means whole number, right? So first, before we go further, let's see how many vectors are there in the set X. Since we have x1 plus x2 plus x3 plus x4 is 0, so it is possible with 1 1 0 0 vectors that is present in this set X. If I can check now, we'll have A vector, B vector. So the set of vectors that we are having, let's say corresponding to this combination, I'll get A plus B, because two slider will operate on A and C. So we'll have A plus C. This will give A plus D. We have all combinations of that, all 6 combinations. B plus C. This is B plus D. And we have C plus D. So all 6 permutation will get set X contains A plus B, B plus C, C plus D, A plus D, A plus C, and B plus D. And from this combination we are getting 2A, 2B, 2C and 2D. So now we have a set of 10 vectors here, 2A, 2B, 2C and 2D. Now the beauty of question was in understanding the question itself. Okay, so the question was S denotes the set of 4 elements of subset X. So S is this. Now S is a 4 element subset of X, such that there is further condition. Let T belongs to it means T is a member of S. So let's consider any 4 element subset. Suppose this 4 element I took. Okay, and if I can take any element of this, let's say A plus B, so A plus B is basically T, that's a member of S. But there is a restriction. The restriction is, okay, like for all those subsets S, if T is an element, it must contain the element 2D. So the question was 2D must be element of T. So if that's the case, it means I know like 2D is fixed now, right? So the question was the number of possible sets T such that the 4 elements of set T are coplanar. So now I know I have to pick up 4 vectors such that one of the vector is fixed to 2D. So now how many remaining vectors we can pick up such that all the 4 vectors will be coplanar. So that's the condition. So now we can do case making. Let's say if 2D is one vector. Okay, so we can take a case where the other vectors can be, let's say, A plus B in some combinations, other is C plus D in some combinations, and so on and so forth. Just to make our life more simpler, what I can do is, without loss of generality, I can assume one of the vector as 0. Because let's say if you have origin over here and we have a point D, so this is position vector of D. So I can set the origin itself to point D. So that will make this term as 0. So we have 2D vector is 0 vector. Similarly, this becomes C and A vector. So our new defined set is origin. So now I have to select 3 of them such that all these vectors, let's say alpha, beta, gamma and origin are coplanar. Means they are on the same plane. Alpha, beta, gamma and origin. Now origin doesn't impact the question now smartly. So just we have to check whether these 3 vectors are coplanar. So here smartly we can do case making. One case making, let's consider a case when only A and B is present in the system. Okay, so alpha, beta, gamma belongs only to the combination of A and B. So we can have A, 2A, B, 2B, or a plus b. They are only possibilities. Now as long as a and b is present in system, let's say we have one vector as a and other is b and one itself is origin. Now if the fourth vector I am taking any linear combination of a and b, definitely it will be in the same plane, right? So out of 1 2 3 4 5 I could select any two of them. So there is 10 ways of doing that. Now in these 10 ways I can give guarantee. Suppose you select a plus b, a and 2b, definitely those three will be coplanar and origin doesn't impact the answer. In the similar fashion I can select second case. So this is case 1. We can do second case by selecting a and c. So let's say I selected a, c, 2c, 2a and a plus c into picture. So with this case also the number of coplanar vectors that will be forming is 5c2. In fact we have to select 3 of them, so it's 5c3, but 5c3 same as 5c2, so it doesn't matter. Okay. So I can tell it's again 5c3 and which is same as 5c2 or 10. So we have case 2 will give 10 vectors. Similarly, let's say we have now AB we have done, AC we have done. What about BC? So again one vector is origin and we can have B, 2B, C, 2C and B plus C. So out of again this 5 choice I can select 3 choice which will give 10. So case 3 still limited. So till now what we have done, I have selected all vectors which is combination of purely A and B, purely A and C and purely B and C. So 30 is guaranteed. Now let's see, is it possible to have any other combination, mixed combination? So let's say if I take suppose A, B and if I take AC and 0. Okay, so now I have taken mixture of ABC. So we will count this case separately. So is it possible that these 4 are coplanar? Of course, again 0 I ignore. So is it possible to have AB and A plus C coplanar? Now that is not possible. Okay, देखो, if you will see the box of AB and A plus C, you already know from box product property this can be written in that form 1 0 0 0 1 0 and 1 0 1 times box of ABC. Now since ABC is non-coplanar, so this quantity is non-zero, right? इसका मतलब इस that को क्या होना होगा, जीरो होना होगा, लेकिन ये that जीरो होगा ही नहीं क्योंकि आप चेक कर सकते हो 1 से we are getting 1 into 1 minus something. So this that is clearly what, which is not. It means the only possibilities of selecting this vector alpha beta gamma should be such that this coefficient that must die. Okay. That is still clear just by looking these vectors. So let's say if you have A vectors and B vectors. So now A plus C, since C is not in the same plane as A and B, so A plus C will be in different plane, hence they cannot be coplanar. ठीक है. So is there any other possibilities for coplanarity? अभी एक possibility है, suppose मैं A plus B ले लूँ और C ले लूँ, ठीक है. So now you can clearly see with what vector if I will take A plus B, so basically we are generating again like some ABC kind of a stuff 1 1 0, right? C when I'm taking, so I'm taking 0 0 1. So now you can clearly see for this that to be 0, what should I keep here? If I expand along the second row, तो यहाँ पे 1 के साथ अपन के पास क्या आना चाहिए? 1 के साथ these two element must be 0, right? Because if it is non-zero, then definitely that will not be 0. I hope it is clear. Why? Because the only way that can be 0 is one of the row, let's say here R3 is directly in proportional with R2 or R1, or it is linear combination of first two. Now linear combination cannot happen because for linear combination you can see it demands 1 1 1. It means A plus B plus C vector, और ये तो possible नहीं है. So जो देखो कितना logical है, तो ये होगा ही नहीं, तो R3 को proportion में होना होगा. Now it cannot be 2 times of A plus B because that's not in the system. The only possibility it must be 0 0 2. इसका मतलब with A plus B C we must have 2C vector. Now this is again not so surprising. Clearly I can see A plus B vector will be in some direction. C is another vector not in the same plane as A plus B. So if I take just scale C by some amount, of course this 3 vector is fundamentally 2 only and it must be in the same plane. And of course origin I'm not talking about because default it is there. तो यहाँ से एक पॉसिबिलिटीज आ गया आपका केस 4 से A plus B और C के साथ ABC के साथ एक ये कॉम्बिनेशन आएगा. Similarly with the symmetricity B plus C, A and 2A will give one answer. So this is case 5. And one more solution was there by symmetricity, which is A plus C, C and 2c. Right? So these are three extra possibilities that we are getting. Okay. Now again you can tell, sir, what about a plus c, a and 2a wala possibilities? Okay. A plus c, a and 2a wala possibilities. So that is already taken care of, because when a and c combination I have taken, when I have taken a and c combination, this is counted. Similarly, this is counted. So case 6 is also gone, because I want mixture of ABC. ठीक है, तो a plus c के साथ the valid combination that I am making, because in case 6 if you do like a plus c, c into c, it's repetition case we have already considered. तो यहाँ पे अलग variety चाहिए, so b into b, this we are not considered as a mixture. So we have 3 cases here. So total answer is 10c3. By symmetricity we are selecting 3 times plus 3 extra cases, so which is 3 into 10 plus 3 is 33. So this was a good question on this problem. Let's try one more question, just as a bonus question. Suppose we have ABC belonging to a real number, and there is a vector B which is AI plus BJ plus CK, such that magnitude of 6A equals magnitude of 3B, magnitude of 2C equals 6. Okay, so the question is, if three non-coplanar vectors, if three non-coplanar vectors are chosen from the set of B, okay, so how many such ways are there, or how many such ways are there to choose three non-coplanar vectors from the set of vectors B. अब देखो सबसे पहले यहाँ से तो आपको क्लियरली दिख रहा है that mod of A will be 1, similarly mod of B will be 1 and mod of C will be 1. So it means A will be plus minus 1, B is plus minus 1 and C is plus minus 1. So how many vectors are there in this set? 8 vectors. Those 8 vectors can be written as I plus j plus k. We have minus I plus j plus k. We have I minus j plus k और I plus j minus k. तो अगर मैं इसको अल्फा ले लूँ, बीटा, गामा एंड डेल्टा, सपोज दीज आर 4 vectors, other 4 will be just minus times of this, right? Minus alpha, minus beta, minus gamma and minus delta. So now out of these 8 vectors, how many? 3 of them are non-coplanar. So it is very easy, क्योंकि I can clearly see out of alpha minus alpha, okay, beta minus beta, gamma minus gamma and delta minus delta. You have to see how many of them are non-coplanar. Now clearly this alpha, beta, gamma, delta are non-coplanar because they are not in the same plane. ठीक है, why and how to check it? क्योंकि आप देख सकते हो इस दोनों का neither linear combination है third. Suppose if I take alpha plus beta equals gamma, so clearly it's not, because 1 minus 1 will give 0, because 1 contains 1 and at least 1 contains minus 1, so that will give 0, and 0 means you have only j plus k kind, so that the structure is not there. So at the first place, how many opportunities are there? I can freely put any 8 vectors. Okay, let's say I kept alpha over here. Now for non-coplanarity, I cannot put any combination of alpha, means I can't put alpha or minus alpha. So how many options are there? 6 options. Let's say out of this 6 options, I kept beta, okay, or minus beta or delta, whatever. So now how many options are there? Now we have 4 options, because I can't keep plus minus alpha because of first row restriction. I can't keep plus minus beta because of second row restriction. So now we have 4 options. ठीक है, तो अब सपोज मैं यहाँ गामा पुट कर दिया, तो अभी मेरे पास टोटल नंबर ऑफ केसेस कितना आएगा? 8 इंटू 6 इंटू 4. लेकिन अब देखो, अब इसमें एक्चुअली प्रॉब्लम क्या है? जो मे बी इन द फर्स्ट सेलेक्शन आई हैव सेलेक्टेड बीटा एंड देन अल्फा देन गामा, or maybe in the first selection I have selected gamma then alpha then beta, because I am selecting alpha beta gamma, but the order is also counted here. But when I am selecting like from the set V, which is set of alpha, beta, gamma, delta, minus alpha, minus beta, minus gamma and minus delta. So when I am selecting just 3 vectors out of this set, clearly order doesn't matter. So whether you select alpha beta gamma or beta alpha gamma or alpha gamma beta, it's basically same. So 8 into 6 into 4 is our counting, and how many times? Because we want these 3 to be identical. Actually we don't want their permutation or dancing to be in picture, so we'll divide by 3 factorial. Final answer इसका जो आ गया that is 32. So there are 32 ways of doing this. You could also think about this question from cube perspective. आप ऐसे सोच सकते थे, because you can assume okay all these represents vertices of cube 1 comma 1 comma 1 minus 1 comma 1 comma 1 and so on. So you can think it's this vertices V belongs to the set of minus 1 comma 1 whole cube Cartesian product of this. So from there also you can clearly see of the coplanarity, because we have diagonals of the cube. Okay, so until and unless they are on the same face or opposite a and minus a, definitely they'll be coplanar. So these are the two perspectives from where you could easily think of this question. One could also think otherwise, in the sense like he could first find number of ways of finding okay coplanar vectors, and then out of total he can subtract. So total you already know, out of 8 possible vector, if I select any 3 of them, so it's a factorial by 5 factorial into 3 factorial, which will give you 6, 7, 8, so it's 56. Now how many of them are coplanar? अब इसको चाहो तो तुम क्यूब के परस्पेक्टिव से 6 ले सकते हो, या फिर ऐसे परस्पेक्टिव से ले सकते हो. अब कोप्लानिटी के लिए अगेन यू कैन सी इफ आई पुट अल्फा एंड बीटा, so we want either that combination alpha plus beta. In fact we can have any combination alpha plus 2 beta or 2 alpha plus 10 beta and so on and so forth. But here clearly like none of these combination will work because the coefficient is just 1. तो यहाँ से भी अगर आप कैलकुलेट करोगे तो 56 माइनस 32 जो भी आएगा 24 जो कॉम्बिनेशंस आया वो प्लेनर हो जाएंगे. और वो देखना बहुत ही आसान है, क्योंकि अल्फ़ा के करस्पॉन्डिंग नाउ यू डोंट हैव चॉइस इन लाइफ. अल्फ़ा के करस्पॉन्डिंग आपको माइनस अल्फ़ा ही रखना होगा कोप्लेनिटी के लिए. और यहाँ पे आपके पास कितना ऑप्शंस है? यहाँ पे आपके पास 6 ऑप्शंस हो गए, कुछ भी रखने का. ठीक है, फिर तुम बीटा के करस्पॉन्डिंग भी वो रख सकते हो और गामा के करस्पॉन्डिंग भी वो रख सकते हो. तो विल हैव वन केस लाइक अल्फ़ा माइनस अल्फ़ा इन बीटा एंड सो ऑन सो. सो दिस विल गिव 6 पॉसिबिलिटीज़. फिर आपके पास क्या आ जाएगा? बीटा माइनस बीटा से भी 6 पॉसिबिलिटीज आएगा, गामा माइनस बीटा गामा से भी 6 पॉसिबिलिटीज एंड डेल्टा माइनस डेल्टा से भी 6 पॉसिबिलिटीज. तो 24 पॉसिबिलिटीज आएगा. 56 माइनस 24 32, इससे भी आंसर. तो आपके पास 3 तरीका है. या तो आप निगेशन का आर्ग्यूमेंट दे दो, कॉम्प्लीमेंट्री इवेंट फाइंड करके फिर उसको सब ट्रैक कर लो, या फिर तुम इसको विजुअलाइज कर लो क्यूब के वर्टिसेस पे, और वहाँ पे भी आसानी से तुम ऑरिजिन को फिक्स कर लो 0 0 0 और वर्टिसेस को 1 1 1 और माइनस 1 कॉमा 1 क्रॉस माइनस 1 कॉमा 1 क्रॉस माइनस 1 कॉमा 1 इस फील्ड में लेके चले जाओ और फिर वहाँ से आसानी से विजुअलाइज कर लो. ठीक है, या फिर सबसे आसान तरीके आप डायरेक्ट कोप्लेनरिटी से कर लो और फिर सब ट्रैक कर दो. So I hope you have enjoyed this lecture and moreover understood like इसको PNC with vector synthetic how we handle. Thank you. Have a good day.